Continue from the previous video, we should talk about the data categories first. So when we collect the data, we have two different categories. The first one is quantitative. You also can say that's numeric number. Or they can be categoric. So the categoric actually kind of like qualitative. So what does that mean? For example, for the category, it's not really you can using the continued number for that. Sometimes, for example, we want to get the income level. We are not using the number, but we're using the three categories. We have low income, low income, middle income, and high income. So that's the ordinal style. And also sometimes you have the nominal data type. For example, we only know our sample individual, they for different political party. So for those data, when you collect that, they are not really based on the data is number. They just a string if from the programming point of view. So they will be just a string or the letter or just an object. So that cannot be using the number to represent for that. So they are categoric. So we talked about that before when we do the Python programming, when we try to process our data. If we really want to using the number to represent the categorical data, then you need to find a way to see how to interpret those data into the number. Or you may just skip the data for get more the statistic information. So that's categoric data. So mostly we want to have the quantitative data. So those quantitative data, of course, they represent by number. So still we can separate into kind. They can be discrete, not continuous, or they can be continuous. So the discrete can be like interval. For example, they are between 5 to 10, or you only have the number 1 or 2 or 3. Or they can be ratio, or you want to be possibility like equal to greater than or less than 0.1 or 0.2, or the possibility equal to 0.1. So that's discrete data. Discrete data, you only have specific value. Even you still can have the interval and the ratio. They have the specific value. They may not continuous. So like sometimes the ratio can be continuous. You can have the possibility less than 0.1, then from 0.1 to 0.5, from 0.5 to 1. Or the interval, they are connected to each other. You have your income from under 5,000, so 5,000 to 50,000, or above 50,000. So that's your data category. So that's why at the end of previous video, we should talk about this data category first. Then you will see for different characteristics of the major scale. That's why you can see we have 4 different categories. Then they have different type of variable. So then you can see they can have identify group, or they can have identify ranking. So that will be all different. And the most important thing you can see here, because the nominal and ordinal, they are categorical. So that's why you cannot really get the mean or median or mode data from that. But the quantitative data, we can get that. So after you understand the characteristic, so different data category, so then we can give you the example for that. So that's one categoric data. So they are quantitative measure within a data set. Categoric data is usually represented by the count frequency or portion. So the portion equal to the count divided by total. So example, like here you see those data we have frequency, how many count, and the proportion. But one thing you can see, the data is belong to different data type, different type of cancer. So that's why they are categoric data. So when we try to represent that, they try to graph that, you cannot really use the continuous, the number on the x-axis. Instead, they have different data, different cancer type. But even the y-axis, they do have the number to represent. So that's why you can see usually if you want to represent those information, you only can using the bar chart to display. So that's categoric data. Let's see the quantitative example. So the quantitative example, numeric measure of a data set, the subcategory can be discrete and continuous. So we see the discrete variable, for example. So you can see here the discrete is for the red blood count. We only have thinking about 7, 800, 850. So we have specific number. So then from those things, you have the number of the individual, how many people, and we have the proportion. So you can see here, we try to get the information for the count and the frequency. But here, when we try to categorize that, you will see they have the numeric number, but they are not continuous. So the next one, right, we're still using the quantitative data, but now you can see they are continuous. So you can see here, we still try to get the count, how many, and the frequency using the proportion divided by the relative frequency. So then here you will see we're using the data category is the height of the kids. So then we have the range for the kids between 20 inch to 25 inch, how many? Then 25 to 30, 30 to 35, something like that. So that's why you can see the data, you're using the continuous variable. So the value cannot be assert or exact. So that's why we give them the range. The value that's be continuous variable can take are infinite and uncountable over the real number line. Within a range, continuous variable can take infinite number of value. So that's when we try to collect the data, you will see the variable you try to categorize that. You have different kind of category. You can have quantitative or just a category for the subgroup. So after you know the data, variable data type, then one thing is we will talk about how you will collect the data. So one thing is when we do the sampling, we will need to know we have some sampling step. So the first thing we need to determine the population to be observed, to be surveyed. So then we will determine which variable to measure and summarize to calculate. So that's why you need to know your variable is what kind of data. So then you will decide the sampling design to employ of the collecting the data. So what means the sampling design? Definitely after you decide your population, then you need to see in what kind of method we will use to choose the sample from the population. For example, some people, they want to get the questionnaire to get the feedback, or they just specific to find some data they can collect from. So which kind of sample from the population and how you will get that method to collect the data. Make sure it's the random sample. It's the sample for which every individual in the population has an equal chance to be selected. That's what we mean the random sample. Because sometimes you cannot try to get specific time to do the survey from the population, because maybe certain time only certain people would show up. So that's why when you try to get your sample, you need to make sure they are random. So what mean they are random? That means all the individual in the population, they all have equal chance can be selected or show up. So that's why your random sample need to be unbiased one. Your sample need to be trustworthy for inference purpose by law of probability. Your random sample comes with a margin of error due to the sample-to-sample variation. So larger random sample provide better insight regarding to the population. Simple random sampling is a sampling technique which will conduct without the replacement. So that we all need to keep in mind how we will collect our sample data. So then we need to make sure those sample data is not a biased one. So when we say bias, that here is couple example about the bias. So bias, unlike confounding bias, is difficult to measure. For example, if a depression patient does not answer truthfully, the bias cannot be ascertained. So when we talk about the bias is underestimate or overestimate of the true value for the population due to the sample technique. So here the bias we only focus on when you do your data sampling, maybe some technique issue you didn't meet. So that's the bias came from. So here you see like the self-interest bias. They have voluntary response bias. They have non-response bias. They have the leading question bias. So maybe your question is not or implies something to guide people to answer. You have social acceptability bias. You have selection bias. You have sampling bias. You have undercoverage bias. So those bias is all possible happen in your sampling. So that's why we need to pay attention to see when you do the sampling, you need to recheck. Do you possibly including those bias in your sampling? So if we can avoid those sampling, we can avoid a lot of error. So here we also talk about some error possibly happen. So the first thing is the sampling error. So this error due to difference between sample measure and the population measure. The estimation of population parameter is subject to the sample-to-sample variation. So this error named standard error can be approximately numerated using the various sample statistics. This error can be attributed to the chance variation of statistics within the different sample. So that's why here the sample error is according to the different sample-to-sample variation. But you also have some error is non-sampling error. So this error caused due to the inaccurate data collection technique. So actually it's your sampling technique caused the problem. So it's not came from your sampling error. So that's why the sample estimation, when we try to estimate the sample, they will equal to the parameter plus the bias and plus the chance for the error. So that's why you can see the bias and the error won't affect your sample estimation data. Some error also came from your probability sampling. So what is the probability sampling? It's the sampling technique in which the probability of the selecting one individual is the same as the probability of selecting any other individual in the population. So that's what we say. You need to make sure every sample individual being selected is the same. That includes simple random sampling, stratified random sampling, clustering random sampling, symmetric random sampling, and multi-stage sampling. You also have non-probability sampling error. So non-probability sampling is a sampling technique in which the probability of selection one individual is not the same as the probability of selecting any other individual in the population. So those possible happen too. So that's including in the convenience sampling, voluntary sampling, and the quota sampling. So that's our first lecture file for the introduction for